you today. Okay, don't have to read this. These are the, like this chapter, in this chapter, there are these few things that you need to know. So at the end of the topic, you check against all this. So there will be how many objectives for you? There will be this few for you. The rest don't need. So this one you don't have to do. So you have the definition for energy. It's not very commonly tested anymore. But anyway, it's the ability to do work. So if you are able to like kick the ball, if you are able to push the table around, if you are able to flip the book, or you are able to cycle, that means you have energy. Okay. Then one thing you need to note is you have to know the SI unit for joules. Then scalar quantity, I think you will learn later. So it just means that energy is not affected by direction. The amount of energy is not affected by direction. It's not too important at the moment. So there are a few down here. There are many kinds of energy. So you have gravitational potential energy, elastic potential energy. Then the rest, you have light energy, you have electrical energy, etc., etc. So we will focus on this. Focus on this. Then you may have the rest down here that you also need to know, but it's not in this chapter. So nuclear is not tested. So this one, the one. Then we have all this. How do you know whether something has gravitational potential energy? You have any idea of that? Or rather, maybe say, let's say, has your school teacher gone through this topic? Then I know what to say. Yes, no. Has the teacher talked about it? Has the teacher talked about it?
No.
No. Okay. So why am I going through this topic? You want to learn in advance. So gravitational potential energy, we will come back to this slide again. So there's this thing called mechanical energy. Mechanical energy is split into two types, which is kinetic and potential energy. Then we'll come back again later. So kinetic energy is something that a body, you and me, or maybe the ball, or something that you throw, all these things have, if they are moving, something that is moving, then they have kinetic energy. So if I have, so something, this is a hill or a cliff or whatnot, then someone stands down here and this person is not moving. So if this person is not moving, that means this person has no kinetic energy. So if I have a ball and then it's rolling back and forth, because it's moving, so maybe say it's moving at 5 meters per second. So because it's moving, it has kinetic energy. Okay? Can? So if I have some dude down here sitting on the bicycle, then it goes about, okay, then it's going this way. Does this person have kinetic energy? Yes. No.
Yes.
Hmm.
Because
So
it's moving.
it's moving, so it has kinetic energy. So then you will notice I have a formula down here. So this formula tells you or gives you the way to calculate whether how much energy or how much kinetic energy someone has. So this is kinetic energy. M here is the mass of the object that is moving. Or the object, maybe say the ball here. So if this is 5 kilograms is too much, maybe say 2 kilograms. So this ball is moving at 5 meters per second and it has a mass of 2 kilograms. So then V down here is the speed of the ball. So if you want to find the kinetic energy, then I will just do half times mass. Mass is 2 kilograms. Then speed is 5. So I can say that the kinetic energy of the ball is 5 joules. Okay. Then do you notice that I have a bracket down here with J, a bracket down here with kg, and a bracket down here with meters per second? Why did I put it there? Do you have any?
Because that is the SI unit.
For kinetic energy, for mass, for speed. Right? Yeah. Then it is also an indication that when you do calculations, that is the unit that must be used. So let's say if my question, okay, so my question here is 2 kilograms, right, given. So I can just put it into the formula like that. But if my question, right, if my question, what happens is, my question is, I wrote 500 grams. The ball has a mass of 500 grams. So can I put this 500 grams into the formula here directly?
No, not must convert to kg.
Yes, so you have to convert it to kilograms, then you can put it in.
Divided by 1000.
Because a lot of students, they do not change their units, and then in the end, you will find that when your calculation, right, your answers will be a few decimal places off. And when you see for answers with a few decimal places off, usually it means that your units are not converted correctly. So back to this, just now you're saying mass, and we have mass and velocity speed in the equation. That means, right, kinetic energy is dependent on mass and is dependent on speed of the object. Follow? Yeah. So now I have object A, which is 5 kilograms, moving at 2 meters per second. Then I have object D moving, okay, object B, which is maybe say 10 kilograms, moving at 2 meters per second. Who has a greater kinetic energy?
Times 5 times 2 square.
You don't have to calculate, right? Do you have to calculate?
When the mass is lower, the speed will be lower and the kinetic energy will be lower.
when no, the speed is given to you, so both of them have the same speed, right?
Yeah.
Both have the same speed, but mass is lower. So the one
The
with
mass is lower,
bigger
means
mass,
the kinetic energy will be higher.
mass is lower, kinetic energy higher.
Yeah.
It's like this: if you have a bigger mass, you have greater amount of KE. Then if you have a greater speed, you also have a greater amount of KE. So we have to
But
convince
the speed
you.
is the same.
Yes, now the speed is the same. So bigger mass equals to bigger KE. Of course, you
Means
can.
It's B.
Hmm?
Means it's B.
Yeah. Yes. So if you so back to this. So that means, right, higher mass, higher KE. Lower mass, then lower KE. This is the relationship. Then if it's speed, then it will be, if it's speed, then it will be lower speed, lower KE. Lower, higher speed is higher KE. Like that. Okay?
Yeah.
So that's what you need to take away. So then we have examples. So we have the word calculate here. You see our question starts and we have calculate the KE here. Like you see, calculate the KE when 0.5 kilograms of trolley move across the floor with a speed of 1.5 meter per second. You say calculate means calculate is used when a numerical answer is required. So in general, working has to be shown, especially 2 or more steps are involved. So need to show working. Usually when it comes to calculation question, right, I will first read the question and write out what is given. So here I have this info. Gosh. So I have, say, this info 1, and then this is info 2. So info 1, that means this is mass. So I write mass equals to 0.5 kilograms. Then speed is 1.5 meter per second. Then number 2 thing I do is to check whether the given information is in the units that the formula wants. So kinetic energy, so I write this equals to half mv squared. So I write these 2 pieces of information down. Then after that, I check whether yes, the formula wants this to be in kilograms. Then speed must be in meter per second. So there's no problem with the given numbers and the units. Then I will write down, take the numbers and then substitute into the formula like that.
But in the question it says 0.50.
Then you just
Then for the mass you put 0.5.
Yeah, like that, no? When a mass of,
That must put a 0.
yeah. Then this question is in 2SF. So your answer will be in 2SF. Or 2SF, or unless otherwise stated. So for now, I'm not very concerned about the SF. So we just get whatever answer that we have to get. So Then I press the calculator. So it's 0.5 times 0.5 times 1.5. Zero 0.5. Did I do something wrong? Did I do something wrong? Hmm? Hmm.
Didn't square.
Yeah. So it should be 0.5625. Alright. But it is not wrong to put into 3SF. No, this is 5.6 3SF. It's not wrong to put this as well. Can?
Yeah.
Then what about the next one? So what information is given to me?
16 kg.
So
And
mass
4
is
times 10 to the power of 5 joule.
then. So then I write the.
Then they ask for a speed.
So it's a kinetic energy question again. So then there's mass. Yeah. So I have the formula with me again. So I just put 4.0 times 10 to the power 5 equals to half times mass 60 times v squared. So what's v squared? What's v squared? Can I get the answer from you?
One, three,
1, 3, 3, 3, 1/3. Then D will be I square 115 meter per second. Now 2SF, that is 120. So in science, right, the final answer must always be in decimal.
And you must also have the working. No working, then no marks.
Yeah, no, okay, so there's a catch down here. If the question is 2 marks, let's say like this. So if it's 2 marks, what happens is 1 mark will be awarded to this one. The rest of the 1 mark is this one.
For the working.
Yes. So if you only write the final answer, you will get 1 mark. But of course, if your final answer is wrong and you don't have working, then you say
no
goodbye.
marks at all.
Yeah, so it's always good to put in the working. And the working will help you check your answer because it will remind you to check. Unless you don't check the answer, then that's another thing altogether. Okay, can I move on?